The first question we're going to do is we're going to try and find cos theta if sine of theta is 0.8 and we're in the first quadrant. Okay, when you see that first quadrant, it's just telling us that no matter what the answer is, it's going to be positive because all of them, sine, cosine and tangent, are positive in the first quadrant. So we are going to use surds as far through as we can. You might need a calculator for the very last step on this page, but you should be able to get pretty far without one. So we learned the Pythagorean identity, So we've got a sine of theta, therefore we can find cos of theta. So if we go to our formula sheet, down here, we're looking at this formula here. So if you have sine of x, you can find cos of x. If you have cos of x, you can find sine of x. So I'm going to go cos of theta plus 0.8 squared equals 1. Decimal's a bit hard to square, but I can make this 8 over 10 and square it, so 64 over 100. And I can take that from both sides. So now cos of theta squared equals 1 minus 64 over 100. Okay, so first step's just plugging into the formula. Second step, we're using a bit of algebra. All right, so what is 1 minus 64? So we can turn 1 into 100 over 100. 6 brings us up to 70, so 36. Okay, and the only thing we've got to get rid of now is this square. So the opposite of squaring something is square root. Okay, which is the same as saying square root of 36 over square root of 100. So we know what the square root of 36 is. And we know what the square root of 100 is. So this question has asked us to go to 3 decimal places. So 6 over 10, we're looking at 0.6. If you want to be extra safe, 0.600, so to 3 decimal places. Throughout these, if you can get it to there and then use a calculator, that's fine. So these ones are very, very similar. We are using that Pythag identity to find our answers with those ones. I'm going to do one more. I might do this one down here. Okay, so they've told us what cos of x is. So if we want to find sine of x, we're looking at that same formula. So let's try it. So cos of x is 0.9 squared equals 1. 0.9 squared I can't do. I can square 9 over 10 though, which is 81 over 100. 2 negatives make a positive. Okay, now we've got to take 81 over 100 away from both sides. So we can make this 100 over 100. 81 over 100, which gives us 19 over 100. Okay, so this here, the fraction, that takes a bit of practice, but you'll get it with this worksheet if you take the time to do it. So we've just got that squared left to get rid of, and we do that by square root. Okay, and if you use your calculator here, I'm fine with that. So just for that last little step, if we put it on a non-calc section, obviously we'll make the numbers work out a bit nicer like we did with the first one. So this is 0.436 to 3 decimal places. Okay, so very, very similar. And we're just working our way through, trying to keep it in fractions and doing our fractions as we go. This one here might seem a bit strange when we first do it, but it's leading into these questions next. So with this diagram, we're given the sides A, B and C, and we want to know what sine of 54 is equal to. So if we go to our formula sheet up here, SOHCAHTOA, and we should remember that that goes all the way back to grade 8, you started learning that. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So you've got it there on your formula sheet, you've got no excuses. So sine of 54, we're looking at opposite over hypotenuse, or A over C. Okay, cos of 54, we're looking at adjacent over hypotenuse, B over C. Cos of 36, adjacent over hypotenuse, A over C. Tan of 36, opposite over adjacent, B over A. Sine of 36, opposite over hypotenuse. And tan of 54, opposite over adjacent. Okay, so which one is equal to sine 54? It's this one here. Cos of 36 is exactly the same. They're both equal to A over C. Okay, so the second one there is very, very similar. We're just trying to take it back to sine, cosine, tangent are triangles, and they're ratios. They're one side over another. So with that in mind, let's have a go at these ones. Excuse me. So we'll do that first one. So sine of A, find sine of A when cos equals 20. So when in doubt, we're going to start off how we normally do, drawing a diagram. So I've got my right angle triangle, and I want to draw a picture of what cos of 20 would be like. So I'm going to put my 20 degrees here, and I'm going to say, well, cos of 20 would be the adjacent side. Let's make that x over the hypotenuse, which would be y. So in my diagram, cos of 20 would equal x over y. Now using that same diagram, they want to know what sine of A is, and they've told us that it's equal to cos of 20. So we already know that whatever sine of A is, it has to be x over y. Now when we did this one, x was the adjacent side and y was the hypotenuse. When we do sine, x is going to be the opposite and y is going to stay the hypotenuse, which is going to look like this. So if we could find that angle, we'd have the opposite over the hypotenuse, which would be x over y, which would be the same thing. So we just need to find out what that angle is. All the angles in the triangle add up to 180. Okay, so that one is going to be 70 degrees. And therefore, A is 70 degrees. Obviously, there's a very quick shortcut to doing these once you get the hang of them, but they will be mixed in with other problems as we go through the unit. So make sure you know when to draw a diagram and make sure you can justify your logic if you need to. Let's try another one like that. We might go, let's go G. Okay, so they haven't given us too much information. They've told us sine of A, so we can draw that. And we don't know what these sides are, but we know that sine is opposite over hypotenuse. Okay, so we've got to find something that would give us cos that would be x over y. Okay, and that would be this angle here. So this would become our adjacent, our hypotenuse. So cos of 1 degree would give us x over y. So therefore A equals 1 because we're looking for the degree. Okay, so those ones might seem simple, but there is a question in your assignment that really looks at that kind of thing. So it's very useful in that regard. So a bit further down here, we are looking at trying to find the value. So they start off pretty easy and they end up taking a fair bit of thinking. So let's start with A. So as I just said, we're looking at sine, cosine and tangent as ratios. We're looking at them as one side over the other. So the best place to start is with the picture. So sine of B. So let's say that's B degrees there. Now we don't know anything about A. We do know that cos of B is 3 over 5. So here, if we used cos, we'd be adjacent over hypotenuse. Okay, it's a ratio. Adjacent over hypotenuse. And we can use that information to find this missing side. And when we had that missing side, we could find sine of B. So if you've had a bit of practice at trigonometry, you might recognise straight away that this is going to be a 3, 4, 5 triangle. But we'll do it a step slower. We'll use Pythagoras' theorem. So big side squared minus little side squared equals x squared. 25 minus 9 equals x squared. 16 equals x squared. X equals 4. Okay, so that gives us the missing side. So sine of B is opposite over hypotenuse. Okay, so this is a very picture-orientated one. Now I'm just having a look at the solutions, trying to find one that doesn't require prior knowledge. We'll go E. Okay, so we're looking at sine of C. Now if you look right back up here, we've got tan of C, which is root 11 on 5. So we can draw that. So tan, so opposite over adjacent, 11 on 5. And we're trying to find this side so that we can find opposite over hypotenuse. So we can go 5 squared plus root 11 squared equals x squared. So 25 plus 11 equals x squared. X equals 6. So sine of C equals opposite over hypotenuse. And that makes cos of C really easy to do as well. We can go cos of C equals adjacent over hypotenuse. Okay, another one that you might get, what angles have we done? We've done B. So let's go cos of 90 minus B is another kind of one you might get. So let's draw a picture. So if we're looking at a unit circle, we're going to go 90 degrees and then we're going to come back B degrees. So we're looking at this triangle here. Okay, we went around 90, we came back B degrees. So that angle in there is 90 take away whatever B is. Now the trick here is finding the other angle. So if B was, say, 30, 90 minus B, this angle would be 60 and this would be 30. If B was 45, we'd have 45 and 45. So this angle up here is actually whatever B is, because whatever we take off 90 is going to fit in there. It has to, because 90, we've already got a 90 there. We need another 90 to make 180. So with that information, we want to find cos of 90 over B. So we want to find the adjacent side, this side, and the hypotenuse. And we need to have a look at what information we know. So we don't know anything out of this one, but we do know something about B. We know that cos of B is 3 over 5. So the adjacent side is 3 to B, and the hypotenuse is 5. We also did some work over here and we found sine of B. And we found out that sine of B, so opposite over hypotenuse, was 4 over 5. So we've got all the sides. And now we've got to look for cos of 90 minus B. So cos of 90 minus B, our adjacent side is 4, and our hypotenuse is 5. Okay, so lots of diagrams in this one.